Hey there, this is a video that's going to help everyone learn how to make a smart port voltage sensor for your FRSky receivers. These boards are discontinued, you can't buy them anymore. So this video is all about buying an Arduino board, something like this, a programming card, which is something like this, or like this, and a bunch of wiring and soldering. Up front, I just want to say, if you don't know how to solder, don't bother. Either find a friend that can help you, or this video is not going to be too useful. You're going to need to be a decent solderer to make these boards. These boards are relatively small, and you're going to have to solder several wires to these boards for them to work. You're also going to need a computer, either a Windows computer, a Macintosh, or a Linux computer. This video is going to show you how to do it on Windows. The reason I'm making this video is I was no Arduino expert. I had no clue about it, and it was a lot of work doing a lot of Google searches to learn the basics of how to program these cards. So this video is intended to hopefully just show you A to Z how to do it without having to do all those Google searches, trying to read a bunch of different documents on what to do. It's somewhat involved, but I've simplified it to the point where I feel anybody can pretty much do this. What you're going to need is this mini board, which I'll document, but it's a 3.3 volt, 8 megahertz. You cannot substitute. It has to be a 328, it has to be 3.3 volts, and it has to be 8 megahertz. Nothing else it can be substituted for that. Alright. You're also going to need a programming card. Programming cards come in a couple different flavors. There's this one, which is called an Uno card. And then you get these small ones. Well, this small one here, even though it was easier to use, it would not reliably copy the code to the Arduino computers. This is actually a computer. So I'm not going to use this in the videos. I don't recommend it. It gave me a lot of headaches. This thing here, it's more money. It's worth it. It works all the time and every time. No headaches. During the video, I forgot to mention one step, so I'm going to mention it up front. There's a large chip in this socket. You have to pull this chip out because we're going to not use this as a computer, but as just a programming card. So you want to remove this chip. If you don't remove this chip, it's not going to work. So don't throw this chip out, but just pull it out for now. Other than that, you're just going to need some heat shrink, and you're going to need a USB cable. This uses the, whatever that connector is called. You're going to need this style connector for this side, and then a traditional USB cable for your computer on this side. These boards are relatively inexpensive. They're a little under $4 on average. You're also going to need some spare servo wires because we're going to be soldering a bunch of wires to the outside of these boards where the holes are. Now, what this board and what this project is going to do is allow you to monitor your voltage from your LiPo battery to your receiver without having to use a balance connector. FRSky typically recommends this if you want to monitor your voltage. These have to be plugged into the balance connector on your battery. This is a pain in the butt to go flying every time, remembering to plug this in. It's also fairly large. This is in line, as I like to call it. It's always going to be plugged in. You don't have to remember to plug anything in. During the video, I'm going to explain how to program OpenTX to show you the voltage and listen to the voltage via voice announcements. Okay, so to program the Pro Mini board, which is done on the right side here, where you have things like DTR, transmit, receive, and a voltage and a ground, I decided to take one of the headers that's included with the board and solder some Arduino wiring pins to the header, because I'm going to use an Uno to actually program these. I had problems with the other types of programming cards. This was, the Uno just always works. I never had any issues with it. So before I put some heat shrink on here, so there's no way I can short these pins out if they get bent, I just want to show you what I did. I just soldered up the pins to the wires that are included in these Arduino kits. Okay, so this is what it's going to look like to get the Uno board ready to program the Pro Mini board. I've done a quick layout of the wires, which goes where. So on the Uno board, you have two sides. You have a digital side, which is where we're going to do our transmit and receive. And then the rest is on this side over here, where we're going to get our reset and our voltage. So basically, if you look at this chart, this is very straightforward what you're going to do. And then I've color-coded everything on the little header that I'm going to use. And these wires are going to what's related to on this document. So all we're going to do is temporarily, I know it's going to be a little hard with the camera, but we're going to put this header on these pins here and just hold it at an angle. When you actually operate the software and you hit the compile and go button, it only takes a few seconds. So you're just going to be holding this for a few seconds like this, and it gets the data from the USB port on the Uno. And this to me is the easiest way to program these Pro Minis and have it work every time. There's other cards out there that will do the same thing, where you don't have to make these wires, but I had all kinds of problems with them. Okay, so the next step, we have to download some software for your computer. I'm going to be using a Windows 10 PC. We want to go to this site here, arduino.cc. Then go to the Software tab and Downloads. Scroll down a bit, you're going to see Download the IDE. And on the other side here is an option for a Windows installer, a zip file, or you can grab it from the App Store. You pick, and pick that option and install the application. Once that application is installed, we need to get the source code for the actual voltage monitor. So we're going to go to a site called GitHub, and it's GitHub, github.com/MikeBland/sportAnalog. Pay attention to the cases. I believe this is case sensitive. Then there's a download button over here, that green button called Clone or Download. Pick that and say Download Zip File. Once you've downloaded the zip file, unzip the file. Pay attention to the location where you're unzipping it. You need to know that location. Okay, the next step is to plug your Uno board into your computer. So that's the USB cable that goes to an open USB port on your PC. This has to be plugged in. And you should have a power light to indicate that it's on. Then we want to launch that IDE that we installed. So launch that program. It's called Arduino, and that's this program here. We have to make a few setting changes. The first thing you want to do is go to the Tools menu. You want to go to the board, and you want to pick Arduino Pro or Pro Mini. That's the only one that's going to work, so make sure it says Pro or Pro Mini. The processor must be ATmega328P, 3.3 volt, 8 megahertz. No other board is going to work. It has to be this board. The third option is based on your PC. In my case, we have to find this board that we plugged into the USB port. And in my case, it was on COM3. Once you have these three settings set, then we want to go to the File menu, Open, and we want to locate that file that we unzipped earlier. And that file is called sportanalog.ino. So navigate to wherever you unzipped that file and open it. In my case, I'm going to cancel since the file is already open. So here is the code. It's written by somebody named Mike Blanford. I'm going to scroll this down just a little bit so you can see some of the code here. So make sure your window looks something like that. It should have that information there. So make sure you loaded the right program. Now the next step, we want to take the board, the Uno board, and we want to take the little computer chip. So we want to take this. We want to take the green pin, and if you'll notice, in the upper right hand corner of the board it says DTR with the switch to the left side. We want to take this board and line those pins up. And you'll see there's a green light here indicating you got power. So just put a little bit of pressure on there so that those pins, you can actually hold it just like that. That's enough pressure here to keep those pins well aligned on that board. Now I'm going to take this out of the picture because we need to get the focus back on the screen. Now we're going to hit this arrow key that says upload. This is very fast. So we're going to upload the code. Now look at the very bottom of that red text down here. This must say verifying with no errors. There can't be any sort of an error there. It must say 1806 bytes of flash verified, and then it has to say done, thank you. As long as you have those three lines, you're good. That means everything worked as expected. If something went wrong, the best thing I can recommend is just try it again. For me, it always worked on the first shot using the Uno board. If for some reason you should have a problem, my recommendation is just reboot the whole PC and try it again. But I've never had a problem with the Uno board and programming these cards. So now the program is done. That's all it took to get that software installed on the card. At this point, you can undo the header from the board, and we'll move on to the next step. Okay, so once you have your Arduino board programmed, the next step is some soldering. We've got to get the wires on here. You will also need a voltage divider. Now, FRSky sells these. You can also make them, but I think it's easier to buy it. The FBVS 01. This is like a $3 item. And the way this works, if you look at it real closely, you'll see on the right side there's a 1S, 2S, 3S. This side, which doesn't have any connectors on it, this goes to your battery or your voltage source. In most cases, it's going to go to our ESC. And what I do is I put a connector on here. Here's an ESC, for example, that I've got. And this is my battery connector, which is an HXT. And on here I have a little pigtail, so when I soldered in my ESC leads, I also soldered in a couple of wires with a connector. I'll put the mating connector on these two wires so I can plug my voltage source into here and make it removable. You could solder this directly to the connector if you want. If you don't want to put a connector on it, that's up to you. Now the other side, you're going to clip this. Just clip this off, and that's going to get soldered directly to the Arduino board. You have a plus and a minus, and I've got a chart here of what you're going to do. The plus is going to go to the A1 port, and the minus goes to the ground. Don't put it on this ground here, because if you put it on this ground here, you won't be able to program the board again. So if there's an issue, once you put solder in that pin, it's going to make it very difficult to reprogram this board. So leave that ground alone. Actually, leave all these pins alone here so you can reprogram it. So voltage divider goes to the ground and the A1 port. Then you've got to make another connector. It needs to have 3 wires. A Servo connector, let's see if we can find one real quick. Here we go. Here's a Servo connector. This is going to go to your receiver. This is going to go to the smart port on the FRSky receiver. These 3 leads are going to be soldered accordingly. The negative, which is the brown lead, it could be black depending on the Servo connector you've got, is going to go to the ground. The plus is going to go to the raw, okay? And then the signal wire, which is the orange or yellow wire, that's going to go to port number 2 up here. You can see they're labeled 9 down to 2. So you solder that to 2. And that's all the soldering you're going to have to do to get that done. We've got the voltage divider circuit. We've got the 2 wires going to the board. We've got 3 wires for this servo wire going to the S port on the S8R receiver. On the connector going to the ESC is a little pigtail coming out, and that's going to the voltage divider. I usually put these on a connector. You could obviously solder them directly in. That's up to you. So what I do next, once I know this is working, is I get some goop, and I put some goop over these wires to act as a strain relief. And when that's dry, I then heat shrink it up and put a piece of heat shrink on. So I'll show that in the next step of the video. But let me show you what it looks like on the radio so you know what to do once you have this working. So I've got a Radio Master T16 here, which is running OpenTX. And if we go to the model options and we go to telemetry, what you're going to have to do the first time, I've already done it, but I'm going to do it again. I did a discovery of the sensors, and that's going to add this A2 setting. First thing I like to do is relabel A2. That's the voltage. So we'll go in here, and I like to call it volt. Okay. Now the next thing you have to do is this ratio. The sensor is not calibrated for the voltage correctly, so you're going to need a one of your LiPo checkers that can tell you the voltage of your LiPo. I've got one here from Hobby King. I'm going to plug this into the balance port on my Turnigy battery. This is a 3S battery. Okay, so the voltage is 11.22 volts. So we're going to go down to this ratio setting here. And if you notice on the top, it calls it sensor 6, 9.7. So we know the voltage is 11.22. So all we're going to do is we're going to press enter. And we're going to change the sensor voltage to be 11.2. There we go. So the ratio is 15.3. The voltage is 11.2, which agrees with the LiPo checker. We press enter. That's a one-time thing. Now you've got the proper voltage calibrated. So you can return out of there. And now you can see it says volt in the telemetry options. So then what you want to do next is go over to your logical switches. And I've got one set up here. And it's already on volt. So I'm saying if A is less than X, this is a 3 volt pack, so I either set it to 9.9 or 10. Let's make it 9.9 under load. I also have this on my throttle lock switch. So SB is my throttle lock, so if the throttle is locked, the alarm's not going to go off. This way on the bench, if you're running a lower voltage, you don't have to listen to the radio constantly looping that it's a low voltage. Okay, so I'm going to return out of that. We're going to page over. Then we have to go over to the special functions here. And I'm saying again, if throttle lock is off, that's my SB switch, play a value. And we have to change that. We're going to look for volt. And you don't want plus or minus, you want the actual voltage. The plus or minus is the lowest voltage and the highest voltage. So you want the real-time voltage, which is just volt. All right. I'm going to loop that every 30 seconds so that while I'm flying, every 30 seconds it's going to announce my voltage. Okay. Just as a quick note, you can see here, this is my throttle lock. I'm saying if the SB switch, which is a 3-position switch, if it's not on, then the throttle is locked. So if it's not in the upper position, the throttle is locked since it's a 3-position. So return out of that. And here's the logical switch for playing the low battery warning on SF7. Okay? So, if we were to unlock the throttle, I'm going to unlock switch SB.
11.2 volts.
Okay, it just reads the voltage off, 11.2. And I'm not sure, yeah, I have this set for 30 seconds. So every 30 seconds, it's going to announce the voltage while you're flying. "30 seconds is always a long time when you're waiting for it."
Volts.
Okay, so that's how that's going to work. Okay, another quick note. On your main screen, I find it helpful to put the voltage. So I have the real-time voltage over here, and I have the lowest voltage over here. So when the motor is on, obviously this voltage goes down quite a bit. So depending on the maneuvers you're doing, you can put a lot of load on the motor. This will give you an idea of what was the lowest voltage at any point in time during the flight, and this gives you the current voltage. So I like to have both on the screen so I can see what's going on. And just for a note, this is my gyro. My gyro sensitivity is set to T5, so I can trim my gyro
Trim center
by just moving that T5 trim. Okay, so here's with the heat shrink on the board. Now what I do is I take the voltage divider and put that on the back side. The voltage divider has its own heat shrink from the factory. So I embed that into the heat shrink so that it's all just one simple little unit. And you can see some of the goop in there to help act as a strain release so that these wires can't get yanked out. So we have one small thing left to do, and there's a little micro switch on these boards. You can hear that it's not closed, but I'm very worried that the heat shrink is possibly going to make it easier to press that board in. So what I like to do is take a knife and simply go along the metal edge of that switch and cut a window. And then just pick that off of there, so that there's no chance that the switch could get depressed by the heat shrink tubing. Okay? And that's it. One other final note, just so you know, that was rather disturbing. These boards also come in a 5 volt 16 megahertz version. They look identical. There's absolutely no visual way to see what you're getting from the vendor. I ordered these from Amazon. The first batch I ordered, everything was fine. I ordered a second batch, they wouldn't work. I couldn't understand what the problem was. It turned out the vendor, even though I ordered 3.3, the vendor sent me 5 volt versions. The only way to absolutely tell if it's 3.3 or 5 is to put like 9 volts on the negative and what they call the raw pin on the board. It's labeled raw, it's down in this corner here. Then put a voltmeter on VCC, which is over here somewhere. If you put 9 volts in, there's a regulator in these things. The VCC should be 3.3 volts out, no matter what the voltage is here. Don't put a lot of voltage in it. Don't put more than 9 volts into it. If you have the 5 volt version, you're going to get 5 volts out the VCC, and that's sure enough what the case was. So I got a bunch of boards that are useless. These are all 5 volt boards. I can't use them. So I don't know what to tell you as far as how to pick a vendor that's going to guarantee that they ship the right stuff. I was sitting on these for too many weeks before I actually opened them, and then discovered they were no good before I could return them. I mean, luckily they're not terribly expensive. They're about $3.50 a board. So it's not a lot of money, but I ordered 5 of them, so I'm at a few bucks on that. Other than that, this really works good, and I want to thank Mike Blanford for making this source code available to us so that we can make these boards, because they used to make them a number of years ago. Loft Hobbies sold them, and Wayne over at Loft said there was not enough demand to make another batch, which I was really surprised about, because I really like this board. So hopefully this video helped everybody. Hit the subscribe button if you like my videos. It helps me out. Maybe I can get some subscribers on YouTube. And happy flying.